Hi guys, moving on with the next lesson of our unit. We're going to be talking about exponential growth and decay today. These first three examples or questions where we're asked to come up with equations, you can go over them in more detail. They're on the file, obviously they're right in front of you here in our video. They're also in the completed note file as well. For the purposes of our video today, I just want to go over the main points or the main takeaways from these. So part A here says you have 3 cells in a petri dish. The cells reproduce by splitting into 2, and they split into 2 every 4 days. So if they split into 2, that means they're doubling every 4 days. So if you have 3 cells at the start, all 3 of those cells split into 2. Now you have 6 cells after 4 days, right? 3 times 2. After 8 days, you have 3 times 2 times another 2, which gives you 12 cells. So every 4 days, you multiply by 2 because the cells are doubling in numbers. And that's where this 2 here comes from. Okay, so for now, just keep that in mind. We are multiplying by 2 in this case because the cells are doubling every, or they're doubling, in this case, every 4 days. For question B, it's talking about purchasing a car. So you buy a car for $10,000. The car depreciates at a rate of 20% per year. So if the car depreciates at a rate of 20% per year, that means the value of the car goes down by 20% every year. How much do you have left? Well, 100% minus 20% means you have 80% left. So you'll have 80% of the value of the car after 1 year. 80% of that value after 2 years, 80% of that value after 3 years. So 80% converted to a decimal is 0.8. And you can see here, after year 1, we multiply 10,000 by 0.8. After year 2, we multiply by another 0.8, because now we have 80% of 10,000. Then after year 3, we multiply by another 0.8, because we have, again, 0.8 of 0.8 of 0.8 of 10,000. So you can see here that the value of the car depreciates from 8,000 to 6,400 to 5,120. The main takeaway here again is, what are we multiplying by? 0.8, because the value of the car depreciates by 20%, leaving us with 80%, and that's where that 0.8 comes from there. And the last one before we get into the actual formulas is part C, and it says here you invest your summer earnings of $1,200 in an account earning 5% per year compounded annually. Don't worry too much about that compounded annually. We'll deal with that more next unit. For now, just know that that means it's earning 5% interest a year. That's what the annual means. Okay, so what's happening here is it's asking us what's the amount of the investment. Okay, so the amount of the investment after every year, you're going to make 5%. So if I took 5% of $1,200, that gives me $60. My investment after year 1 is not worth just $60. It's worth the original $1,200 I had plus the 60% I earned in interest to give me $1,260. So that's why we multiply by 1.05 and not just 0.05. Because by multiplying, if you look here to the right, if we multiply by 105% or 1.05, that takes into account the original amount we started with, right, the 1,200, plus the 5% we made in interest. So by doing 1,200 times 1.05, it tells us the total value of our investment. This $1,260 includes the original 1,200 plus the $60 in interest. Okay, so every year you make 5%. So you multiply by 1.05 in the first year. Then you take what you had in the first year, so 1,200 times 1.05, multiply it by another 1.05 for 2 years. And then you take that amount and multiply by another 1.05 for 3 years. And you can keep doing this for however long your investment is. You keep multiplying by 1.05 every year. So again, the key here is each year we're multiplying by 1.05 because you're earning 5% in interest, and that's where this 1.05 comes from. Okay, so there's a little background for what we see here in terms of our useful formulas. So for any questions you have such as these, you're going to use one of these 4 formulas. Okay, doubling time, And the giveaway here for doubling time here is the 2. Half-life, we haven't done one yet in the examples, but we'll do one coming up. Well, in any case, the half here represents half-life. Percent increase and decrease. Increase is represented here because we're adding, right? And then here decrease is because we're subtracting. So what do all of these variables mean? This A with a little 0, or A naught, is the original amount that you start with. Okay, so in the example of the cells, we had 3 cells to start with. All right, in the example of the summer earnings, we had 1,200 to start with, so that would be 1,200. A is the final amount. So how much money do you have after a certain number of years would be A. How many cells do we have after a certain number of days would be that A there. T is the time elapsed, right? So if the question said with the cells example here, how many cells do you have after 20 days? Well, the T would be 20 in that case. D is the time for the amount to double, the doubling time. Okay, and the question would tell you that. H is the half-life. So if it's a doubling time question, you'll be given the doubling time. If it's a half-life question, you'll be given the half-life. And I, which you see here in percent increase and decrease, is the percent. And remember to always convert that percent to a decimal when you're plugging it in. So in our percent increase example up here, it was a 5% increase. So you convert that to 0.05. All right, so 1 plus 0.05 gives us the 1.05 that we're multiplying by. Okay, so those are the 4 formulas you're going to use for any of these questions. So looking at our examples here, the number of bacteria in a culture is growing exponentially. It doubles every 6 hours. Right, so right away there, it's telling us it doubles every 6 hours, so we know we're going to be using the doubling time equation, which is right there. Okay, so what other information do we have? Initially, there were 5,000 bacteria. So initially, right, meaning the amount we're starting with. So this value here is 5,000. How many bacteria would there be 2 days later? So here you'll see in their equation we have 1, 2, 3, meaning the T, and 4, meaning the variable D here. 4 variables. We'll always be given 3 of them, and you'll have to solve for the 4th one. So here it's asking us how many bacteria are we going to have after 2 days, so we're trying to solve for A. Right? We're trying to solve for this A here. We know this is 5,000. We know it's doubling time, so that this 2 comes from our formula or equation that we started with. The T is the time elapsed, and D is doubling time. So we know our doubling time is 6 hours, and we know T, time elapsed, is 2 days. The one thing to be careful of is that T and D have to be in the same unit. So here, doubling time is 6 hours. We need bacteria to be in hours as well. Sorry, not bacteria. We need the time elapsed to be in hours as well. So how many hours is 2 days? Well, 24 hours in 1 day. 2 times 24 tells me 48 hours. So just be careful. Anytime you're given T and D in different units, make sure you convert them to the same units. Once you do that, we have enough information here. So plug in the 5,000, plug in the 48, plug in the 6. 48 divided by 6 reduces to 8. And just remember, when you get to this point here, don't do 5,000 times 2 first, because exponents comes first in BEDMAS. So we need to do 2 to the power of 8, and then multiply by 5,000. So then your final answer is 1.28 million, or 1,280,000 bacteria after 2 days. Okay. Example 2. Radioactive thorium-227. So this is this 227 has nothing to do with the question in terms of a number we're using. It's actually the name of this chemical. I'm not a scientist here, but it's in the name. So just don't be careful and don't think this 227 is a number that actually has to go with or go into the formula. Okay, has a half-life. So there again, now we know we're going to be using the half-life formula, which you see right there. Has a half-life of 18 days. There are currently 60 milligrams of thorium-227. So currently 60 milligrams, so there's the 60 milligrams there. Half-life is 18 days. And then part A says, how much will remain after 45 days? So there's our time elapsed. So we have 1 2, 3 variables given to us. We want to figure out how much of this will remain after 45 days, so we're solving for A. So we literally go to our formula, plug in our 60 here. Again, if you want to write this as a half or 0.5, doesn't really matter. Plug in the t-value of 45 and plug in the half-life of 18 days. You can simplify that to 2.5. And again, remember, do this part first, 0.5 to the power of 2.5. And then multiply that by 60. And that tells us after 45 days, we'll have 10.61 milligrams remaining. Okay. And one thing that should make sense is, because it's half-life, right, we are decreasing the number of milligrams of thorium-227 that we have. So this number should be less than the number we started with. Okay. If for some reason you get a higher number than 60 down here for your answer, then you know you've made a mistake, and you should go back and see or identify that mistake and fix it. Okay. Part B, how long will it take to decay to just 3.75 milligrams? Okay, so here we are being asked for something different other than the A value, which we were asked for in the previous 2 questions we did. So we still know that we start with 60. We still know the half-life is 18 days. Now we know at the end we'll have 3.75 milligrams. What we need to figure out is how long will it take. So what are we solving for? The t-value. Okay, so this one's a bit trickier because we still plug in our numbers like we normally do, but now we have to isolate for t. So first plugging in our numbers. So this A value is 3.75 because that's what we're left with, right? It's saying how long will it take to get to 3.75. We started with 60. And we know the half-life is 18, but we need to figure out the t-value. How long will it take? So first off, from this line to this line, divide both by 60, both sides. Leaves us with 0.0625 equals 0.5 to the t over 18. Now what I need to do is, if you recall to a previous lesson, to solve for a variable when it's in the exponent, we need to have the same base on both sides. So our exponent here has a base of 0.5. What I need to do is express this 0.0625 with a base of 0.5. And to be quite honest, looking at that, it would be pretty tough for me to figure out how can I express this as a base of 0.5. So what I would do is just take my calculator and do trial and error. Do 0.5 times 0.5. Does that, do 0.5 times 0.5. Does that give me 0.0625? No, it doesn't. Multiply it by another 0.5. Does that give me 0.0625? No, it doesn't. Multiply it by another 0.5. Does that give me 0.0625? It does. So I know 0.5 times 0.5 times 0.5 times 0.5 is equal to 0.0625. So I can rewrite this as 0.5 to the power of 4. Once I have the same base on my exponents, then I can once I have the same base on my powers, I can equate the exponents. So 4 equals t over 18. Multiply both sides by 18 tells me it'll take 72 days. Okay. Last question here is a percent increase question. It's talking about population. We have a population of 240, and it's growing at 6% per year. Determine the population of the village in 15 years. Because it's growing, it's percent increase. So we're solving for A naught. What do we start with? 240 people. What's the percent increase is 6. Convert that to a decimal, 0.06. And the t value here is 15 because it says 15 years. This here should say 15 years. All right, so we plug in all of our numbers, go ahead and solve, and remember again, do 1.06 to the power of 15 first, then multiply by 240. And then that will tell us that we'll have approximately 575 people in the village after 15 years. So round this to the nearest whole number because we can't have a point something of a person. So 575. Okay, so just remember, always convert your percent to a decimal. So 6% converts to 0.06. Plug that in there. The amount of time is 15 years. And how many did you start with? 240. Okay, so hopefully that makes sense. And again, any questions at all, please feel free to email at any time. Thanks, guys.